Okay, let's continue with the exercises. I've done some of them in the when ended up this problem, which is similar to the one we have here, right? Now the uh, question here consists of logarithms within logarithm. Okay, we have actually three bases in this equation: base 2, 3, 4. And what we do is convert to exponential form each time. And if you remember, or yeah, this was yesterday's uh, lesson. If you have a logarithm, then you can convert it to exponential by doing sort of a mnemonic, like where you draw arrows in a counterclockwise fashion and rewrite as a to the y. Okay, you should have the same base. Start with the a, and instead of x as the input, we have now y. A to the y equals. Now note that here the input is x, y, but here the input is y, the output is x. They have the same base. One is logarithmic in form, the other is exponential. So if we apply that to this problem, so we raise 4 to 1, okay, and that would be equal to the expression inside the logarithm there. So if we rewrite, we will have the following: 4 to the 1, this. Okay, so let me write that first. Log base 3 of log base 2 of x equals 4 to the 1. Okay, again, one more time, 4 to the 1 equals this. And 4 to the 1 is 4. Then we repeat. We convert again to exponential. 3 to the 4 equals this. 4 log x base 2 equals 3 to the 4. And 3 to the 4 is 81. And one more time, we write in exponential form, 2 to the 81 equals x. Or equivalently, x equals to the 81. And that's your answer there. I think it would be too large to write this one in numerical form. Consists of a lot of what they call this, places, and I'm not sure even an ordinary computer would be able to give that to you correct to all the I mean numerals or decimals in that number. So you can leave, in other words, your answer in this form if we have too large a number, spatially unexplored. 2 to the 8. Okay, any question on this? Similar problem in the previous lecture, which I will be uploading later. Okay, next. So the equation is logarithmic again. Let's read the problem first. So logarithm of x base 7 quantity squared minus 3 log x base 7 equals negative. Now, does that form look familiar to you? What form is this? If we use a transformation, quadratic. If we denote the common term there, log x base 7 by some other variable. So we can use y, we can use t. So let t be logarithm of x base 7 And if we rewrite everything in t, we'll have t squared minus 3t equals -2. And so we just see it as a quadratic equation. We do not see the logarithm there, okay, in this one. So we solve this first. We know how to do. And this is factorable. Giving us two possible values, 1 and 2 for t. And then that's when we solve for x. We revert to x. So we have two cases, equals 1, equals 1, equals 2. Now, how do we solve each case? Anyone? How do we solve each case? X. Let's consider the first one there, log x base 7 equals 1. What is that?
Sir,
Yes?
i-rewrite po ulit siya as exponential. So, bale, log x base of 7 equals 1 magiging 7 raised to 1 is equal to x po.
So
Tapos,
x is 7 to the 1.
opo.
Okay, so 7 to the 1 equals x, or x 7. And we do the same thing for the other. So 7 to the 2 equals x equals 7 squared, 49. And then write in set notation if required. So you have two. Okay, next, we have a system. I'll try to absorb as much technique, or yes, technique as you can, because I'm just answering as many exercises as we can in the given time, although we really have a lot of time. So you will see several techniques that I will be employing to solve equations as well as system. So you may not be able to follow yet every calculation, but at least you should see the idea, okay, in the idea involved in the solution of the problem. So as in this one, what technique can we apply to solve the system? Anyone? Well, there are several, but the best technique would be to use the method of what we call elimination. Perhaps that's what will be. How do we eliminate? We can
Sir,
eliminate, yes.
pagdating na po. Pwede pong i-multiply po by -2 yung unang
Mhm.
logarithm.
Sige, pwedeng yun ang gawin natin. Or, kung ayaw mo munang mag-handle ng logarithm, i-subtract mo lang yung dalawa, di ba? Cancel na si log x. You can try that out para mas ma-eliminate yung x na. But, okay, para makita natin ulit yung technique ng pag-convert to exponential, sige, ang i-eliminate natin yung y. So, we multiply the first equation by negative. And then we add that to the second. So thus eliminating y. And what is -2 log x plus log x? -2 log x plus log x is just like your -2a plus a. Right? That's -a. So this is negative log x. Then 2 minus 4. Then we multiply by -1 or divide by -1. We have log x equals 2. And we know this is base 10. Then again, the technique of rewriting in exponential form. So 10 squared, okay, is equals x. Now you have just solved for x, so it remains to solve for y. And we plug that into one of the equations in the system. So let's plug x equals 100. And what log 100? That's base 10. What should you raise 10 to get 100? That's 2. Or if you're not sure, but you should be familiar with the definition of the logarithm by now, you can use your calculator. So y plus 2 equals negative 1. So y equals negative 3. And ordered pair, set notation. Yeah. So try this out. Oops. Let's go. Okay, that's correct. Now, instead of directly tackling the system, sometimes it would be preferable to use a change of variables or a transformation so that you can merely see a linear system, okay, instead of a system, or maybe we can call it a logarithmic system that consists of logarithm. So denote, okay, one of the common expressions there by A and the other by B. Then you first solve for A and B, right? So at least you evade the problem of having to deal with logarithm in case you make an error, okay, with the manipulation. It will give you some uh, credit. You get this part, right? So you add equals 1/2, then it would be easy to find B first. So plugging in should give you, okay, plug in A equals 1/2 here. Kita natin, ano? Nalagyan natin dito. So B is 5/6 minus 1/2. And that is, this is 2/1. So in other words, you solve the system, you get those values for A and B. So I assume you know how to do system of linear. So next we revert back to the original variables x and y, and A equals 1/2. So we have this. Okay, that's for A, and then for B, that's 1/3 for log y base 3. Sorry, log 3, tama ba? Base y. Then you just solve for x and y. So for x, you rewrite this one in exponential form. You have 1/2 equals 5. And for x, you just have to make this 1. So you square, okay, both sides. 1/2 times 2 is 1. So that's just to the 1. Or then same thing for the other. You cube, get y equals 27. And this is your answer. Any question? Okay, next. So you are to solve here for the indicated variable, which is x. Sometimes an equation may contain more than 2 independent variables. It has to be indicated. So y is given explicitly in terms of x. Now you're to give x explicitly also in terms of y. So let me answer this one. You are to solve for x. So x is here. It appears only once on the right-hand side of the equation. So the thing would be to isolate x and then put everything on the other side of it. How do we begin? We inspect the equation and we see that the right-hand side contains a logarithm. And one of the techniques you already know by now is that you can manipulate a logarithmic equation by converting it to exponential, okay, exponential form. And this is base E, okay, that's base E. And since the two are change, or I mean the logarithm is on the right hand side, we can draw arrows in a clockwise. Okay, so e to the y, okay, we're converting now. E to the y, okay, equals square root of x minus 1. Okay, that's one way. Or some students prefer to do it this way. Since they are equal, then if I raise e to both, then the results are also equal. Huh? Since y equals this. So these two are all equal. And then we know that e and ln cancel out. I mean, they are inverses. So we go back to the input square root of minus 1. Okay, remember again, e to the ln x is x. This is logarithm base e. This is exponential base e. So they unto each other. Whatever the input is, that will be also the output composition of them. Okay, or again, one more time, e to the y equals square root of x. And don't lose your sight on x. That's what you are taught. And we have to be able to isolate x on one side, but still there's a radical in the way. So we will have to remove it by undoing it, and that is by squaring both sides of the equation, thus, okay, eliminating the presence of the radical there. And then for the left-hand side, we apply the laws of exponents. We multiply y times 2 or 2 times y. That's 2y. And then see that x is now finally solved. X equals e to the 2y plus 1. In fact, later on when we go to finding the inverse of a given function, and one of the functions is logarithmic, this will also be the technique that you will be employing. Okay. So any question on this one? Otherwise, I want you to practice on the next. Okay. I want you to use a logarithm. Okay, you're solving for n. Okay, I think you have to use a logarithm here. Okay. Okay, the answer given by Veranga is correct. So solve for n, you have to isolate n first. It's on the right-hand side. So you transfer everything on the left-hand side or transpose from the two words transfer and position. Okay, so transfer all other terms on the other side. So you divide everything by a. A is now on the left-hand side. Now you still have two variables on the right-hand side, r and the one you're solving for, n. So this time you need a logarithm since the right-hand side is exponential. Okay, and you're solving for the exponent. So you know that it's the logarithm that you have to use. And the base is r. So we take the logarithm of both sides base r. And actually the right-hand side is just the exponent. Okay. What should I raise r to get this? It's -1. Okay, this is logarithm base r. This is exponential base r. So remember, they undo each other, the input. The right-hand side is just n-1. Then we transpose 1. There we have it. Okay, almost similar. So write this one out before we have the last exercise. Okay, base P. You're solving for K. K is all there on the exponent. So you have to use a logarithm, base P. And if you take this to base P log, you get K minus 1 over K. Is there any question? Is there any question on this step? Pag nilogarithm mo yung right-hand side base P, ano yan? Okay, what should I raise P to get? Obviously this one. Okay, and it remains to solve for K. You cross multiply. K minus 1 times 1 is over 1, right? Then K times. Then collect all those with K on one side of the equation, those without K on the other side. So ang may K ito. Ito lipat ko dito. And this one. Okay. So all those with K, I transferred to the left hand side. The others. Then to solve for K, you just have to factor it out. Okay, and then finally divide. Yeah. Okay. Last one. Okay. Okay, let me first use the transformation, then I will go away this one there. So first denote by t the variable e to the x, and you should be able to write e to the next. Okay, since e to the negative is just the reciprocal of t. So the equation now becomes y equals t plus 1 over t all over t minus 1 over t. And before cross multiplying, we will eliminate the fractional expressions within the fraction there. So we multiply by the LCD. Okay. And then we cross multiply. Okay, this first y t squared minus y, this plus 1 times 1. Okay, hello. Then we're solving for x, so that means we have to solve first. We collect all with t on one side. So we transpose t, and those without t transpose to the other side. And then factor out terms, the t squared there, the GC. And you see now that you can isolate t. And then you take the square root of both sides. Then revert back to x. T is e to the x. And then to solve for x, you use the inverse of e to the x, which is ln x, or rather ln. You take the ln of both sides. Take the ln of the left-hand side. It's just that's an identity. Ln e to the x. Okay, ln and e unto each other. Take the ln of the left-hand side again, that's x. Then you take the ln of the. And for now, this will do as an answer, but actually, you can use one of the properties of logarithms to get rid of our radical expression there. As I shall show, bala ko sana next pa to i-discuss na yung mga property. We have this property of logarithms, that the logarithm base a of r to the n is the same as n times logarithm of r base a. What this property is saying is that if you have an exponential inside the logarithm, but their bases are not the same, you can bring down the power of the logarithm. Okay? Bumababa yung power kapag may logarithm yung nilagyan ng logarithm yung exponent or exponential. Now, this one can be written as to the 1/2. And what the property again is saying is that if you have the logarithm of a power, you can drop the power beside the logarithm. One of you gave this answer to. So bumaba yung 1/2. So that means itong dalawang expression na ito pareho lang. Okay? Now, as to the direct approach, can be done. Anyway, pwede nyo namang i-review yung video, no? Pause. Sanbura ako agad eh. Pwede rin direct. Cross-multiply tayo agad. And then, okay. I'm thinking of a different one. Let me see if it can be collect like terms. Pwede rin. So, yan. Tama yung magkapareho na ito the negative factor out. And then i-divide na yung e to the negative x baba dito, y minus 1 dito. And then, di ba, a to the m over a to the n, subtract the exponents. So, x minus negative x. Yun. Then, ln both sides. Okay, kaya napalabas na yung 1/2. Okay? 2x yung left-hand side. So, ito, wala ng radical agad. Then, divide by. Okay, any question? Wala. So, that means I will be seeing you next Monday. Okay, that's it, class. Let me end the meeting.